Hello everyone. Today I'll be discussing the topic of fructose from the chapter of biomolecules in class 12. So I'll start with the screen share. Okay. So fructose is a type of a carbohydrate. It is a monosaccharide. It is generally found, it is found in free state in the form of fruit sugar. We call it fruit sugar. It is a sweetener in the fruits. Okay. It is also found in honey and many sweet fruits. Next is in the combined state. Combined state, it is found as in the sucrose. Sucrose is a disaccharide, okay, which is the disaccharide of D alpha positive glucose and beta negative fructose, D beta negative fructose. So it is found in combination with glucose in the sucrose, molecule of sucrose, that is your table sugar. Now, what is the structure of fructose? Fructose is a ketohexose. It is a ketohexose with the molecular formula C6H12O6, the same as glucose, but the difference is that in place of the aldehyde group, you have a ketonic group. So if I draw the structure over here, so 6 carbons, 1, 2, 3, 4, 5, 6. It's the same way as glucose, CH2OH. This is at third carbon, there is the position of the OH group is on the other side, on the left side. In rest of the carbons, it was on the right side. Same as again glucose. The only difference is that in place of the aldehyde group on carbon 1, you have a ketonic group on carbon 2. Okay, so this is how we describe the fructose. Now, next is the fructose that is found in nature in plants. It is known as D, in fact, D negative fructose. We call it D negative fructose. So you can have like this. Now, what is the meaning of D in this case? D is the absolute configuration. I discussed in the video of the structure of glucose, how do we assign the absolute configuration? So the absolute configuration is same as glucose, that is the OH group is present on the right side. The OH group on the last asymmetric carbon in the chain is present on the right side. So that is why it is D. Next is minus. This minus sign means it is levorotatory. It rotates the plane polarized light towards the left hand side. So it is levorotatory. So this is how we represent the structure of the fructose. Now the same as glucose, fructose also has a ketonic group as well as the OH group. So this can also undergo bonding, intramolecular bonding. Okay, and as a result, what will be formed? It will form a ketal. It will form a ketal. So if I draw the structure again over here, so this is CH2OH, and then I'll show the cyclization. 5, 6, CH2OH over here. This is your fifth carbon. Third carbon. and you have a ketonic group over here. Now this OH from here, this OH from here, the oxygen which carries a lone pair. Okay, so it acts as a nucleophile. So what will it do? It will attack the carbonyl carbon. It will attack the carbonyl carbon, whereas the hydrogen will attach itself to this oxygen. Okay, so this is how the reaction will proceed. So as a result, you get two types of configurations. One is the new OH group that is formed is towards the 1, 2, 3, 4, 5, 6. Again, rest of the molecules are the same. Rest of the groups are the same. And the new OH group which is formed is on the right hand side. Okay. Of course, this has reacted. So if I show the cyclization, I can show it this way. If this OH group, the new OH group is on the right side, in fact, this will be on the other side then. Okay. So this is how you get the new OH group. Fine. If the cyclization occurs from the other side, second carbon, this is your second carbon over here, and this is first carbon. First and second. So this shows the change. 1, 2, 3, 4, 5, and 6. So 2, 3, 4, 5, and 6. So this is a sixth one. Same way. OH, H, H, OH. So now the CH2OH group on this is on this side, whereas the new OH group that is formed is on this side. So this is your, so accordingly, you will get two anomers. You get one more asymmetric carbon atoms, due to which you get two isomers. Okay, which are these isomers called? They are called the anomers. So if OH is on the right hand side, we name it as alpha D minus fructose. And this is called OH on the left side, we call it beta D minus. Minus is again the optical rotation, fructose. Okay. So the same way I can draw the Haworth projections, the way we are drawn in case of glucose molecules. Okay. So the Haworth projection will have a 5-membered ring. Okay. Starting from 2 oxygen, then 2, 3, 4, and the 5th carbon. This is 5th, this is 6th. So you get a 5-membered ring like this. So this is carbon 2, this is 3, this is 4, and this is carbon 5, to which you have CH2OH group, which is attached over here. So let's see which are the groups attached on these carbons. As we are done in case of glucose, the groups which are present on the right hand side, they are drawn below the ring. They come below the ring. So OH is on this side. Okay, and the other side, if I check again, C2, CH2OH on the left side will come on top of the ring, and the OH on the right side will come below the ring. Okay, so next is again C3, you can see the configuration, OH up, H down. Okay, then C4, you can check H, OH. And this is your H. Okay. So what is this structure called? What will you call this structure? This will be known as alpha D negative fructofuranose. We call it alpha D negative fructose furanose. Why furanose? Because this structure is compared with that of furan ring, like this. Okay, so 5-membered ring, one of the atoms is the oxygen in the ring, 4 carbon atoms, the same way. So it is called fructofuranose. And the new hydroxyl group, the OH group that is formed, the new one that has come over here. So this is a new OH group. Okay, so this is alpha isomer, and then the beta isomer. You also do, that also can be drawn the same way. So this is carbon 2, carbon 3, carbon 4, carbon 5, CH2OH is carbon 6, and the same way. So if you see C2, CH2OH below the ring and OH above the ring. Okay. Rest of the groups will remain at the same position. So what will you call it? As again I can show, where is a new OH now? On this side. Like this. Okay. So this is, how do we name it? It is named as beta D minus fructofuranose. So remember, alpha and beta are the new configurations that are obtained because of the formation of 2 anomers. Okay, and in fact, in your sucrose molecules, you'll find this isomer. Sucrose is a combination of, it is a combination of alpha D positive glucose plus beta D minus fructose. Okay, so it is a disaccharide which is obtained by the linkage between these 2 monosaccharides. So with that, I finish this video. Thank you and stay safe, all of you.